in the last lecture, what I've explained you, okay. OX is the axis of spin, right, and OY is the axis of precision, okay. So this is only in the case of the steering. Now you know what is axis of spin, axis of precision, okay. Now you have to just remember that OX is the axis of spin when you're looking from the top view, okay. So from the top view, you will understand whether the shift is turning to the left or turning to the right, and OY is the axis of precision, okay. So this is the case of the steering, okay. Now we have started drawing a diagram, okay. So how to draw the diagram in this case? So let us say what is the direction of viewing. Direction of viewing is this. So here is your observer. Always remember where is the observer, and the rotation is clockwise, right? So rotation is clockwise means what? And the shift is taking a left turn. Shift is taking a left turn, right now. Shift is taking a left turn. So how we start? We draw, first of all, draw a vector. So now observer is here, okay. First of all, locate the observer. Now if you locate the observer, so this rotor is rotating clockwise now. So clockwise means what? The X point will be away from the observer. So mark point X, OX, and mark the arrow. See, this arrow X is away from the observer. Why? Because it is rotating clockwise. Is it clear? So you have to just fix in the mind where is the observer and where what is the rotation, clockwise and anti-clockwise. So if it is clockwise, X point will be away from the observer. So let us say if it was anti-clockwise, so your observer was here, you will write like this. This is the X point, this is the O point. So this will be your so X point is towards the observer or away from the observer, that you have to just understand, okay. So similarly here is the same case. So now we are taking a left turn, okay. We are looking from this point, तुम्ही इथून बघताय observer, and you are taking a left turn. So now when you are taking a left turn, okay, if you are looking from the observer is looking from the back side. What is the back side called as a? Back side called as a stern, and what is the front side called as a? Front side is called as a bow, okay. So obviously you will always take a turn from the front side, okay. So take a turn from the front side. This X point will shift upward, right? This X point will shift upward. So you will get a point X dash, okay. Now X dash. Now where you will get the effect of gyroscopic couple? You will get the effect of gyroscopic couple in this plane, that is the XOY. This XOY is nothing but the XOY, remember, is nothing but the gyroscopic couple, okay. So in this case, your observer was here, okay. I will rub out this all, and now your observer was here, okay. Now you have to bring your observed position here, right? You have to bring your observed position here. So now X is moving towards X dash. See, remember, X is always moving towards X dash, and active gyroscopic couple. What is active gyroscopic couple? Is that it is nothing but a applied couple. So active gyroscopic couple is always in the direction of X dash. Is it clear? Active gyroscopic couple is always in the direction of X dash. Now see that this active gyroscopic couple is equal to the direction of X dash. It is away from the observer. So now reactive gyroscopic couple. Now reactive gyroscopic couple is towards the observer. Now tell me how this reactive gyroscopic couple will act, clockwise or anti-clockwise? Anybody? See, we have to look
Anti-clockwise.
anti-clockwise, okay. So where it will act on the third axis. Which is the third axis? That is OZ axis, axis of gyroscopic couple. तर तुम्हाला एवढं लक्षात आलं असेल की about the axis OX, the disc is spinning, the axis OX is precessing about the axis of precision, and because of this, the active gyroscopic couple is created. Reactive gyroscopic is created. This reactive gyroscopic couple is anti-clockwise, and it is acting on the third axis. Which is the third axis? That is OZ axis, and where you can get the effect in this plane XOY axis, plane of gyroscopic couple. And now we'll see the effect. What is the effect? See, it is acting anti-clockwise. Where I am showing in this front view, that is in the plane XOY. I am showing it, okay. So now you can see the shift is taking a left turn. Where you can see the shift is taking a left turn from the top view, that is in the XOZ. म्हणजे तुमची शिफ्ट कुठे टर्न होते, लेफ्टला का राईटला, यू विल लुक इनटू द XOZ plane, that is the plane of precision, and this gyroscopic couple which is acting anti-clockwise, reactive gyroscopic couple is acting anti-clockwise. You will see in this plane XOY, plane of gyroscopic couple. Now tell me what is the effect? What is the effect here? Be fast, I have to move forward. because already I have explained you this. I am just repeating this on the request of some students. Okay, tell me what is the effect now? What is the effect? This is a bow and this is a stern. What is the effect? Be fast.
Bow is rising.
Yeah, bow is raising and see you have to solve the problem on this guys. And stern is lowering. So raise the bow and lower the stern. Okay. So have you understand this? I will take one more example if you want. Uh, so this is now already I have explained. Let us take one more example. Okay. Now see, what is this stern? Okay, stern. Observer is where? Let us take this example. Observer is at the stern. Direction of rotation is anti-clockwise. Okay, and the ship is turning right. Okay, now ship is turning right. So how will you draw the diagram? Yes, I will show only one or two examples. Rest. See, total there are 8 cases. Total there are 8 cases. I have already shown. Let's see. Let's draw this. Okay. So first of all, where is the observer? Let us say you draw. See how you start. How you start with the help of a without animation. Now let us say you don't have animation. How you will remember this? Okay. So just draw a simple line. Mark this as a stern. Mark this as a bow. Okay. Now where is the observer? Observer is at the stern end. Okay. Now, what is the direction of rotation of the propeller? Anti-clockwise. It is anti-clockwise. And where the ship is taking a turn? Ship is taking a right turn. Okay. Now, first of all, tell me how will you draw the arrow? Be fast. First of all, tell me how will you draw the arrow? Anti-clockwise, stern, and right. Anybody? How will you draw the arrow?
Towards the observer.
या ऑब्झर्व सी एवढंच लक्षात ठेवायचं क्लॉकवाईज असेल अवे फ्रॉम द ऑब्झर्वर अँटी क्लॉकवाईज असेल टुवर्ड्स द ऑब्झर्वर ओके सो वेर इज द ऑब्झर्वर नाउ आई एम ड्रॉइंग अ वेक्टर डायग्राम दिस इज द ऑब्झर्वर ओके आई विल टेक another color pen so it will be easily understanding so this is my point x now my point x will be towards the observer right why my point x is towards the observer anybody because when I am looking from the stern end that is the observer end I am seeing that the rotor is rotating anti-clockwise so it will be towards the x so now next right turn now the ship is taking a right turn so where will be my x point move see right turn means what you are taking here okay now see now what you do this is the x point this is the o point na? This is the x point you mark here this point so this will be o point this will be x point and now you can see that आता आपण टर्न कुठून घेणार आहे टर्न आपण नेहमी फोडून घेणार आहे व्हेकल विल ऑलवेज टर्न फ्रॉम द फ्रंट बिकॉज स्टेरिंग सिस्टम इज ॲट द फ्रंट so let us say that ship is turning towards the right now tell me where will be the point x shift upward or downward anybody where will be the point x shift
Upward.
upward how downward anybody it will be upward na right why because see na you are taking a see x is see I am drawing a vector diagram x is towards the observer okay this is the o point सो हे असं खरं करायचं नाहीये पण तुम्हाला समजण्यासाठी जस्ट टू मेक इट सिम्पल व्हॉट आय एम सेइंग दॅट जसा तुमचा ॲरो असेल टुवर्ड्स द ऑब्झर्वर एक्स ओ मार्क हियर ओ अँड मार्क हियर एक्स सो नाव यू कॅन सी दॅट सिन्स आय एम टेकिंग अ राईट टर्न मीन्स व्हॉट व्हेरीवर यू आर लुकिंग फ्रॉम अ बॅक साईड राईट टर्न कुठे असणार आहे तुमचा खाली जाणार आहे म्हणजे तुमचा बी जो ओ पॉईंट आहे तो खाली शिफ्ट होणार आहे मग एक्स पॉईंट कुठे शिफ्ट होणार आहे एक्स पॉईंट तुमचा कुठे शिफ्ट होणार आहे वरती शिफ्ट होणार आहे एक्स डॅश सो एक्स डॅश कुठे गेला तुमचा वरती गेला okay so now I am drawing a diagram so this is my x dash okay now this is my x dash okay so now I have to shift the observer where I will shift the observer anybody this is my observer position let us say I am shifting my observer position here okay now what is the direction of x dash direction of x dash is away from the observer so this is what active gyroscopic couple so active gyroscopic couple is same as the direction of x dash so where will the reactive gyroscopic couple will be the towards the observer reactive gyroscopic couple will be towards the observer so what will the effect आता इफेक्ट बघा इफेक्ट कसा असणार आहे ह्याच्यावरती हा तुमचा स्टर्न आहे आणि हा तुमचा बो आहे टुवर्ड्स मीन्स व्हॉट इट इज ऍक्टिंग अँटी क्लॉकवाइज सो व्हॉट विल बी द इफेक्ट
Bow right stern dead.
stern will raise yes
Low.
bow will rise stern will raise so same I have highlighted over you can see so this is a vector diagram stern will what stern will lower and bow will rise so tell me have you understand this okay so similarly we have 4 cases see stern clockwise left stern clockwise right stern anti-clockwise left, stern anti-clockwise right, and accordingly you have to solve this one. Okay, I will take one more case. Let us say I will take one more case for your understanding. Okay, now let us say my observer is near the bow, my direction of rotation is clockwise. आता मगाशी जर कोणाला समजलं नसेल तर आता एकदा चेक करा. And direction of turning is right. Okay. Okay. Now let us say we will start. See, what is the condition? Observer is near the bow. First of all, as I earlier said, that draw a small line. Let us say this is a S. Let us say this is a B. Okay. Now where is the observer? Observer is here. From the observer is at the bow end. Observer is at the bow end. Okay. And where is the ship taking a turn? Right side. And what is the direction of rotation? Clockwise. So rotation is clockwise. Now first of all, we will draw a vector diagram. Anybody? Where will we, first of all observe? Okay. Which point will be away? Which point will be away from the observer? O or X?
X.
X point. Yes. Why? Why it is away?
Clockwise direction.
Clockwise. Okay. Now where is the observer? Where is the observer? Observer is at the front end. म्हणजे तो शिपला पुढून बघतोय. Okay. So bow clockwise right. Bow clockwise right. So I will take like this. So this is my O point, this is my X point, and arrow will be away from the observer. Now it is clear. Next. Now ship is taking a right turn. आता ship right turn कुठून घेणार आहे? तुम्ही कुठून बघताय? Observer पासून बघताय. So ship will take a right turn. See, you look from stern or you look from bow. The turn will be same. पण गाडी आपण जेव्हा पुढून टर्न करणार left, vehicle left and vehicle right will always remain same. So where will be the vehicle left? Sorry, where will be the vehicle right? Okay, to make more easy, mark your point. This is point O, so this is point O. This is point H, this is point H. Okay, so now shift is taking a right turn. Okay, now tell me O point will shift downward, O dash, and X point will shift upward. Is it correct? So mark here. So this is X dash point. Okay, so I have marked here. I think तुम्हाला आज clearly झालं असेल. So now arrow कसं mark करणार? Arrow is always from X to X dash. So mark this arrow. And active gyroscopic couple will be always in the direction of X to X dash. Now I am shifting my observer here. Why I am shifting my observer here? Because see, if you go plane wise, you have to look into the plane of gyroscopic couple. But here we are just drawing on a plain paper, so you just remember that shift observer from this position to this position. Now we are shifting observer from this position to this position. Now tell me, where will be the reactive gyroscopic couple acting? Opposite to this. Okay. Now tell me, reactive gyroscopic couple is what?
Anti-clockwise.
Anti-clockwise. Why it is anti-clockwise? Anybody? Why it is anti-clockwise?
Towards the observer.
Towards the observer. Now tell me, what will be the effect? Draw a line. Draw a line. Stern. Let us say bow, and it is acting anti-clockwise. Now tell me, what is the effect?
Bow right stern will be.
Raise the bow and rise the stern. Okay, so guys, there are 8 cases you can solve. If you go by book method or by any YouTube method, they will show you the method of planes. Means what? You have to see which plane is perpendicular, which plane is parallel, and then you have to draw the plane diagram, and then you have to. That is correct method, but this is the easiest method which I have shown you. This is very easy method to understand because it will save your time. Okay. So have you understand, or shall I take one more example? If you want, I can take a last example. Otherwise, I will move to the next point. Anybody, if you want one more example of any another type. Okay, now bow clockwise right, bow anti-clockwise right. Okay, you can take one more example. Bow clockwise left. You can take bow anti-clockwise. So you have a 4 cases for stern. You have a 4 cases for bow. And you have 4 cases for bow. Bow clockwise left, clockwise right, anti-clockwise left, anti-clockwise right. Now tell me, do you want any one more example from this? A typical one? Or you have understand? Please tell me fast. Have you understand? Yes, anybody? Hello?
Yes, sir.
Yes,
Shall I
sir.
take one more example or not? That I'm asking.
No, sir. Understand. Sir, समझ
Understand? You can solve any case. You can solve any case. Okay. See how many cases. So homework. A screenshot मारून घ्या. तुमच्यासमोर screenshot मारून घ्या. Okay. So this is your homework. You have to solve all the four cases and WhatsApp me. Go clockwise left. What is your aim? You have to draw the vector diagram and show the effect. Go clockwise right, go anti-clockwise left, go anti-clockwise right. Okay? Don't do for the aeroplane because aeroplane is not in your syllabus. Do only for the this one. What you can do? Ship. Okay? So these four cases, 1, 2, 3, and 4. Okay? Have you taken a screenshot? Okay, go clockwise left, go clockwise right, go anti-clockwise left, go anti-clockwise right. Okay, so what is your task? Draw the vector diagram, show me the effect. Okay, similarly we have to do this for the stern also. Okay, for this also. These are the four cases, and these are the another four cases. Case number 1, 2, 3, and 4. Okay, these are same: clockwise left, clockwise right, anti-clockwise left, anti-clockwise right. So this is same, but here only the observer is changing: stern, 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 and Z. So total there are 8 cases, and in all the 8 cases you have to draw the vector diagram and show the effect. Show the effect like this: stern down, bow, sorry, stern deep, bow raise, or stern lower, bow rise. Okay. Once you do this, I will be giving you this PPT. Okay, message me yes or no. Can you do it or no? Please message me.
Yes, sir.
Okay.
Yes, sir.
Yeah, okay, thank you. Chalo, next case. Now pitching. So now as a yes. So I hope you have understand the effect of gyroscopic couple when the ship is steering. Now, very important point. Now when the ship is steering left or right, either bow will raise or uh, uh, this. What will happen? Bow will raise or stern wheel lower or vice versa. Okay, but in this case your axis of spin was what? OX. So OX was nothing but the axis of spin. In which case you have to remember this, very important. Steering च्या case मध्ये, in case of the steering, your axis OX is nothing but axis of spin, OY is nothing but the axis of precision. Okay, now already I have explained. If you're absent, watch my recorded lectures, you will get to know what is axis of spin and what is axis of precision. So this is the case of the steering. Now let us understand the case of pitching. Now you know what is steering, turning from left or right, that is the steering. Now what is the case of the pitching? See, ship is sailing on the water. Now ship is sailing on the water means what? It will pitch up and down. जर तुम्ही गाडीचे एक्झाम्पल घेतलं ती पण त्याची पण अशी अप अँड डाऊन मुवमेंट होणार. आय विल शो यू द एक्झाम्पल्स. ओके, सो अगेन नाउ अगेन दिस इज सेम. Okay, now this is a steering condition. This is a steering condition. Ship is turning to the left or right. Okay, or this is ship is turning towards the left or right. Okay, now first of all let us understand what is pitching. Now this is pitching. This is called as a C. First of all, in pitching, you understand the diagram. So this is called as a pitching upward. Can you see? Can you see what is pitching upward means? What pitching? This is called as upward pitching. Okay, means what? Ship is pitching upward, and this is what? Ship is pitching downward. Okay, ship is pitching downward. Okay, now when the ship is pitching upward and ship is pitching downward, what is the effect of gyroscopic couple? That we have to understand. Okay, now basically that effect is related to the port and the starboard. That effect is related to the port and the starboard. Means what? When the ship is pitching upward, the ship will try to move towards the port end, and if the ship is pitching downward, the ship will try to move towards the starboard, or maybe vice versa. That we will understand. So now first of all you just understand what is pitching. Pitching is nothing but the upward movement of the ship. Okay, let me go to the another example. Okay, see, can you see this? This is the picture from where you will understand exactly what is pitching, what is rolling, and what is bouncing. Okay, so bouncing is, let us forget about the bouncing. Now rolling. First of all, see pitching. Pitching means what? Pitching, you have to look from this side. You have to look from this side. Means what? Side view. So whenever you are looking from the side view of a vehicle, तुम्ही व्हेकलच्या साइड व्ह्यूनी बघितलं तर तुम्हाला असं दिसेल that this vehicle or a car is moving downwards or moving this upward. That is called as a pitching. Similarly, your ship will also move upward and downward. See, म्हणजे ह्या सगळ्या गोष्टी एकत्र होणार आहेत. Ship is taking a turn left or right. Again, the ship is also pitching. Pitching means what? It is moving up and because ship is sailing on the water. Try to understand. This was not the case of the aeroplane. And rolling. For rolling, you have to look into the front. Rolling means what? See, rolling is like leaning one side. It is equal to the leaning. So if car is leaning about the axis, let us say this is the x-axis. X-axis. So car is. I will show you one more picture. You will get a better, clear understanding. So now when you're looking from the front, so car is leaning to either this side or car is leaning to either this side. ओके, तो जेव्हा तुम्ही समोरनं बघता तुमची जी गाडी आहे ही एका साईडला लीन होते, आयदर टू द राईट साइड और आयदर टू द लेफ्ट साइड. दॅट इज कॉल्ड एज द रोलिंग. Now, first of all, tell me, have you understand the difference between the rolling and the pitching? Then I will move forward. Because already you understand what is steering. Now I have to understand you rolling and pitching. I have to explain you rolling and pitching. Sorry. So have you understand the difference between the rolling? Rolling साठी तुम्ही कुठे बघणार साइडला. I will show you one more picture. Okay. So this is basically one more picture. Now see. So what is rolling? You have to look from this side. Now this is what, guys, this is what x-axis. Let us say this is point O, this is z-axis, and this is y-axis. Okay. So what is rolling? Mx. Mx is the rolling moment. What is Mx? Mx is the rolling moment. Okay. Mx is the rolling moment. Right. I will explain you what is the effect of gyroscopic couple. That is a later case. Now I am trying to explain you what is rolling and what is pitching. So whenever you are looking from this is the observed position. That is the front of the vehicle. The mx is nothing but a rolling movement. Means what? Vehicle is trying to lean either side. Okay. Now observer is here. Okay. Then my is the pitching movement, and my is the pitching movement. Means what? Vehicle is trying to move up and down. Now tell me, is it clear? Now there is one more condition which is not in the syllabus, but just I will explain it. First of all, tell me, have you understand this mx and my? So mx is the rolling. So where is mx rolling? Mx is rolling about x-axis. So this x-axis is nothing but a transverse axis. See, axis go on a changing. So mx is rolling about the x-axis, and here my is about the y-axis. So my is pitching about the y-axis. So axis changes, transverse axis changes. What I mean to say. Okay, is it clear? And see, this mz is nothing but a yawing moment. It is called as a yawing moment. Yawing moment means what? About the z-axis. See, your vehicle is having a movement about the z-axis. See, कशी movement असणार आहे की तुमची z-axis असेल तर अशी movement. So this movement about the z-axis, that is the mz, is called as a yawing movement. So vehicle is moving about the z-axis. About the x-axis, rolling movement. About the y-axis, pitching movement. Now tell me, have you understand? So same will be the case of the ship. There is no any change. Is it okay? Is it clear or not? Hello, is it clear? Okay. So chalo. Now we'll start with the next procedure. Now we'll see the effect of gyroscopic couple on ship. Now I have explained you what is pitching, what is rolling. Now I have explained you what is steering, and then I have explained you what is the effect of gyroscopic couple on ship during steering. What is the effect? Raise the bow, lower the stern, and vice versa. You are able to draw the vector diagram. Okay. Now effect of gyroscopic couple on the ship during the pitching. Now what is effect of gyroscopic couple on the ship during the pitching? That we have to see. Now first of all, we have to understand what is the axis of precision. Now already see, we have to look from the side view to see the pitching, right? Pitching is what? Upward and downward movement. So first of all, you understand. So when you look from the top view, okay, you will see that for pitching, OZ is the axis of precision. For pitching, OZ is the axis of precision, and OX is the axis of spin. Okay, this is the first point you clear out. Axis of precision and axis of spin. So in case of the steering, OY is nothing but the axis of precision, right? So OZ and OX. This is clear. First of all, now we'll see the effect later on. Now we'll see the effect. Now, first of all, again same. First of all, we will draw the vector diagram. What is the vector diagram? So direction of viewing is what? So this is the observer. So this is the observer. Rotation is what? Rotation is clockwise. कुणाचं rotation clockwise? Rotorचं. So draw a vector diagram. Vector diagram means what? This is the observed position. Now OX is away from the observer. X is away from the observer. Okay, is it clear? Direction of viewing is this. Rotation of the rotor is clockwise. So from observer, my X point is away. Okay, now ship is pitching where? ship is pitching upward. Ship is pitching upward means X point will move where? शिप जर तुमची अपवर्ड पिच होणार सी हा ओ पॉइंट आणि हा ओ पॉइंट मी इथे दाखवतो ओ आणि एक्स. ओके, मग तुम्हाला आता तुम्ही म्हणाल सर मग तुम्ही हा प्लेन का घेतलाय, एक्स ओ वाय प्लेन का घेतलाय, तर ह्या प्लेन मध्ये मला गायरोस्कोपिक कपलचा इफेक्ट दिसणार आहे ना. जेव्हा तुमची शिप पिच होणार आहे अपवर्ड किंवा डाऊनवर्ड, तर मला इफेक्ट कुठे दिसणार आहे गायरोस्कोपिक कपलचा एक्स ओ वाय प्लेन मध्ये. ओके, नाउ फर्स्ट ऑफ ऑल टेल मी, if I am saying that ship is pitching upward, you can see na arrow, tell me where will my point shift? My x point will shift where? Upward or downward? Right, it's very easy, na? In this
Upward.
case, shift upward. So my x point is upward. Okay, my x point is upward. Okay, my x point is upward. Right now, if my x point is upward, let us say this was my observer position. Now I am bringing my observer position. So active gyroscopic couple is where? Where is active gyroscopic couple? Active gyroscopic couple away from the observer. That is reactive gyroscopic couple. Reactive gyroscopic couple. Where is reactive gyroscopic couple?
Towards the observer.
Okay. So what will be the effect? Clockwise or anti-clockwise? What will be the effect?
Anti-clockwise.
Anti-clockwise. Okay. Ata, what is the axis of precision? What is the axis of precision in this case? What is axis of precision and what is axis of spin? Okay, so now let us see what is the effect. See how it is acting. It is acting anti-clockwise, na? So it is acting anti-clockwise. Okay, so the ship will try to move towards which side? The ship will try to move towards the starboard side. Starboard side. So this is called the starboard side and this is called the port side. So this is the case. So this is I have explained you in animatically. Let me make it more easy. जसं आपण म्हणजे सिंगल पेपर वरती आपण बघितलं तसं आपण त्याला इझी करूया. ओके, लेट मी मेक इट मोर इझी. ओके, इफेक्ट ऑफ गायरोस्कोपिक कपल ड्यूरिंग द पिचिंग. ओके, लेट मी मेक इट मोर इझी फॉर यू because maybe someone will not get clear by looking at their animation. So let me make it more easy for you. So let me say that this is a stern. Okay, see whatever I have explained in the last slide, same I will explain again, but in a more easier way. That is a my way. Okay, stern and the bow. Now I am saying that ship is pitching where? Let us take an example. Yes, anyone? I am taking ship is pitching upward. Okay, now ship is pitching upward. Okay, now there are two sides. One is the right hand side. Remember, one is the right hand side. What is right hand side called as a starboard?
Starboard.
Starboard. What is left hand side called as a port? Okay, and then back side is called as a stern and this is called as a bow. Now I am saying that ship is pitching upward. Ship is pitching upward. Okay, so first of all, where you have to look? You have to always look from the top view. In case of the pitching, तुम्हाला टॉप व्ह्यू मधनं बघायचंय. मगाशी मी जी दाखवली ना तुम्हाला टॉप व्ह्यूची डायग्राम, तर टॉप व्ह्यू मधनं जर तुम्ही बघितलं तर तुमच्या लक्षात येईल की क्लॉकवाईज ऍक्ट होते का अँटी क्लॉकवाईज होतं ऍक्ट. ओके, सो तुम्ही टॉप व्ह्यू मधनं बघताय. नाव शिप इज पिचिंग अपवर्ड. शिप जेव्हा अपवर्ड पिच होणार आहे, मला सांगा ही डायग्राम कशी येणार? कशी येणार ना?
बॉल वर जाणार स्टर्न.
Yes. Okay. So bow will move. I will call it as a B dash, and this is let us say S point, and this is let us say B. I will call it as a S dash. हे क्लिअर झालं? तुम्ही कुठे आहात? तुम्ही कुठे आहात ते तुम्ही पर्यंत क्लिअर. तुम्ही टॉप मध्ये आहात. ओके, तुम्ही टॉप मध्ये आहात ते तुम्हाला क्लिअर झालंय. चला, आता शिप कुठे पिच होते? अपवर्ड पिच होते. ठीक आहे, आता बी डॅश वरती गेला. आता जेव्हा तुम्ही टॉप मधनं बघताय, आता मला सांगा, हॅलो. ओके, आता बी डॅश ची मुवमेंट कशी आहे? आय विल टेक वन मोर पेन सो इट विल बी क्लिअर टू यू. बी डॅश ची मुवमेंट कशी आहे? अशी आहे ना, अशी आहे. म्हणजे बी टू बी डॅश म्हणजे ऍक्टिव्ह गॅरोस्कोपिक कपल कसा ऍक्ट होणार आहे? टुवर्ड्स ऍक्ट होणार आहे. आणि रिएक्टिव्ह गॅरोस्कोपिक कसा कपल ऍक्ट होणार आहे? ऑब्झर्व पासून अवे का टुवर्ड्स? येस. सो रिएक्टिव्ह गॅरोस्कोपिक कपल विल ऍक्ट अवे फ्रॉम दिस. ओके, मग रिएक्टिव्ह गॅरोस्कोपिक कपल जर तुमचा ऍक्ट अवे होणार आहे, क्लॉकवाईज रोटेट होईल का अँटी क्लॉकवाईज रोटेट होईल?
क्लॉकवाईज.
क्लॉकवाईज. ओके, आता तुम्हाला हे क्लिअर झालंय की रिएक्टिव्ह गॅरोस्कोपिक कपल हा क्लॉकवाईज आहे. ओके, आता जेव्हा तो रिएक्टिव्ह गॅरोस्कोपिक कपल क्लॉकवाईज ऍक्ट होईल, तर मगाशी मी तुम्हाला त्या अॅनिमेशन मध्ये दाखवलं तसं तुमची शिप, तुमचे इफेक्ट काय असणार आहे ह्या रिएक्टिव्ह गॅरोस्कोपिक कपलचा? या रिएक्टिव्ह गॅरोस्कोपिक कपल जो क्लॉकवाईज ऍक्ट होतो त्याचा इफेक्ट काय असणार आहे? इट विल ट्राय टू मूव्ह द शिप टुवर्ड्स द स्टारबोर्ड साइड, म्हणजे राईट हँड साइडला. तो शिपला कुठे मूव्ह करण्याचा प्रयत्न करणार आहे? स्टारबोर्ड
Right
साइडला, राईट हँड साइड म्हणजे स्टारबोर्ड साइडला. तेच मी तुम्हाला मगाशी तिथे दाखवलं ना. इज इट क्लिअर? हॅव यू अंडरस्टँड? ओके, मी तुम्हाला आता दुसरी केस दाखवतो म्हणजे तुम्हाला अजून क्लिअर होईल. नाउ लेट अस से सेकंड केस इज, आय विल चेंज द कलर पेन. सी, हे तुम्हाला समजणं गरजेचं आहे, मग बाकी सोपं आहे. लेट अस से दिस इज अ स्टर्न एंड, this is a bow end, okay, and you are the observer looking from the top, okay. Now ship is pitching downward. आता शिप जेव्हा डाऊनवर्ड पिच होणार आहे, शिप जेव्हा तुमची डाऊनवर्ड पिच होणार आहे, तेव्हा मला सांगा हा तुमचा बो पॉइंट कुठे जाईल? असं येईल ना.
बो खाली जाणार आहे.
या दिस विल बी बी डॅश अँड दिस विल बी एस डॅश. ओके, सो बो विल बी डाऊनवर्ड्स. ओके, सो नाव एरो कसं दाखवणार मी? एरो कसं दाखवणार? डाऊनवर्ड. तर शो द एरो. सो ह्या एरोच्या डायरेक्शन मध्ये मी काय दाखवणार? ऍक्टिव्ह गॅरोस्कोपिक कपल. आणि ह्या डायरेक्शनच्या मध्ये मी काय दाखवणार? रिएक्टिव्ह गॅरोस्कोपिक कपल. नाव टेल मी, हाऊ विल द रिएक्टिव्ह गॅरोस्कोपिक कपल ऍक्ट? रिएक्टिव्ह गॅरोस्कोपिक कपल कसं ऍक्ट होणार?
Towards the observer.
टुवर्ड्स द ऑब्झर्वर, म्हणजे अँटी क्लॉकवाईज और क्लॉकवाईज?
अँटी क्लॉकवाईज.
Anti.
अँटी क्लॉकवाईज. आता जेव्हा तो अँटी क्लॉकवाईज ऍक्ट होईल
Anti-clockwise.
तेव्हा what will be the effect of this reactive gyroscopic couple when it is acting anti-clockwise?
Shift will tilt left side.
Yeah, ship will tilt to the left hand side. म्हणजेच कुठली साइड?
Port.
म्हणजे हे दोन, एवढे दोनच इफेक्ट आहेत. आता स्टेअरिंग मध्ये बाळांनो किती केसेस होते? स्टेअरिंग मध्ये किती केसेस होते?
4.
4 कसे?
8.
केस होते ना. ह्या केसमध्ये आपल्याला फक्त दोनच केसेस लक्षात ठेवायचे. कुठले दोन केसेस? आयदर द शिफ्ट इज मुव्हिंग टू द पोर्ट साइड और आयदर द शिफ्ट इज मुव्हिंग टू द विच साइड? स्टारबोर्ड साइड. ओके, आता हे सगळं एकत्र होणार आहे, एकदम होणार आहे. मीन्स व्हॉट? लेट अस से शिफ्ट इज स्टीअरिंग and shift is pitching also. So let us say shift is steering, bow will raise and stern will lower, vice versa, and simultaneously either your ship will move towards the port side or either your ship will move towards the starboard side. Now tell me, have you understand? So which method is easy for you? That plane method or this method which I have shown in the paper? Which method is easy for you to follow? Hello? Or you are, or it is very easy to understand this method. This method means what? Draw a plane, XOY plane. So XOZ plane is nothing but what? The plane of precision. Okay. In case of the in case of the this one pitching, OZ is the axis of precision and OX is the axis of. So draw this diagram, draw this plane, and see the effect. Either pitch is moving upward or downward. So it will be same. So tell me which method you will follow. This plane method or which one I have shown you? See, na, same I have shown you. Same I have shown. See, pitch is pitching upward. This ship is pitching upward. So it will try to move. The ship will try to move towards the right side. If ship is pitching downward, it will try to move towards the port side. Okay. So is it clear, guys? It is clear or not? Guys, please tell me fast. Is it clear or not?
Yes, sir.
So can you solve any case now? Okay, thank you so much. Now we'll solve some. Now I have to now we'll do some derivation because finally you have to solve the problem. You want some formula. Okay. Now see what I'm. Now once you have understand this, once you have understand the effect, so what is the effect of pitching? Ship will either move towards the port side or starboard side. Okay, and steering effect आपण बघितलं. So let us say that again. In this case, okay, so now here you will see that the axis OX, okay, the axis OX, okay, sorry, this axis is OZ, axis of precision. This is not the axis, okay, this is actually this is not the axis of precision. Okay, this here we are looking from the front of axis of precision is OZ and axis of spin is OX. Okay, so doesn't matter about that. Okay, I will write here Z. Is it clear? Okay, so now what you can see from this, First of all, what is pitching? Pitching is nothing but the up and down movement, upward or downward movement. Okay. Now, in this case, first of all, the first point you have to understand that what is theta and what is phi. Okay. So theta is nothing but the angular displacement of axis of spin. Angular displacement of axis of spin OX. Axis of spin OX. Hello. 1 second. Okay. So let us say that this is a z axis. Okay. So axis of now first of all, what is theta? Try to understand what is theta. Theta is nothing but the angular displacement of the axis of spin from the mean position. Angular displacement of the axis of precision means what? Axis of precision means what? The axis of spin OX is trying to turn about OY, right? Now, axis of in this case it will be Z. Okay, so axis of spin OX is trying to turn about the axis OZ. That is called as the axis of precision. Is it clear? So here in this case, now this axis of OX is, first of all, you try to understand that the pitching of ship is assumed to be a simple harmonic motion. Is it clear? तुमची शिप कशी पिच होते? Your ship is pitching upward and ship is pitching downward. Okay. So to find out the equation, what we are assuming that the ship is pitching upward and downward with SHN, that is a simple harmonic motion, because we have to consider some equation. And what is the equation of simple harmonic motion? Equation of simple harmonic motion is x is equal to x sine omega t. Have you derived this in 12th standard or maybe first year or second year? Have you derived the equation of motion for a simple harmonic motion? Anybody? Say yes or no. Have you derived the equation for the simple harmonic motion? You maybe असं असेल ते x is equal to a sine omega t, right? X sine omega t or x sine omega t. In the vibration, we will derive this. Okay. So guys, same here. When the ship is pitching upward and downward, to do some derivation, I am assuming that ship is pitching with simple harmonic motion, that x is equal to s sine omega t, right? And what is omega t? Omega t is nothing but the theta, no? Omega t is nothing but the theta, because theta is equal to omega into t, right? So same guys here. So that is why I am assuming this theta and phi. So here, why I am taking two things, theta and phi? So theta is nothing but the angular displacement of the axis of spin. We see. So this axis of spin OX is moving to its new position here. So it will be, let us say, theta. Similarly, when it is pitching downward, it is, let us say, theta, and let us say this is the mean position. Okay, is it clear? And phi. Phi is called as the amplitude of swing. Phi is nothing but the amplitude of swing. Now, what is swing? Amplitude of swing. Amplitude of swing means what? Maximum angle. It is also, phi is also called as a maximum angle turn. Phi is nothing but the maximum angle turn. See, theta is nothing but what? Theta is the angular displacement of the axis of spin OX from the mean position. And phi is also the angular displacement, but it is nothing but the angle of swing or amplitude. See, आता एक साधं तुम्ही लक्षात ठेवा की जेव्हा तुमची शिप पाण्यावरती पिच होणार आहे अपवर्ड अँड डाउनवर्ड. Okay, means what? Ship is pitching upward and downward. Means what? It is vibrating, na? The ship will start vibrating upward and downward. It is like a upward and downward movement. So vibrations are created. So obviously that vibrations will create the amplitude, because vibrations are related to the amplitude. Okay. So what is the maximum amplitude, or what is that maximum angle? So that is denoted by phi. So phi is called as the amplitude of swing or maximum angle turn from the mean position of what? OX. Okay. So I will draw one more diagram here. So let us say this is a maximum angle. So this total angle is phi and this total angle is phi. Is it clear? Guys, मला सांगा तुम्हाला एवढं क्लियर झालं का? Hello? Is it clear what is theta and what is phi? Then I will move on to the derivation. Have you understand what is theta and what is phi? Anybody?
सर फाय आणि थिटा मध्ये डिफरन्स नाही कळाला.
Theta is the angular. See, theta is the angular displacement of the axis of spin. What is axis of spin? What is axis of spin? Whoever is asked question, tell me what is axis of spin? What is axis of spin? आणि या केसमध्ये axis of spin काय?
OX.
OX आहे. OX इज axis of spin. तर हे axis of spin कुठल्या पोझिशनला आहे? लेट अस से मीन पोझिशनला आहे. तर मीन पोझिशन पासून या axis of spinचं या axis of precision, लेट अस से OZ इज द axis of precision ना. OZ इज द axis of precision फर्स्ट ऑफ ऑल. तर जेव्हा तुमची ऍक्सिस या ऍक्सिस ऑफ प्रिसिजनच्या भोवती टर्न होणार आहे, तर ते किती अँग्युलर वेलोसिटी ती टर्न होणार आहे? तर ओमेगा पी, दॅट इज नथिंग बट द अँग्युलर वेलोसिटी ऑफ प्रिसिजन. तर तो किती अँगलने टर्न होणार आहे? काहीतरी अँगलने टर्न होणार आहे ना, मग तो अँगल म्हणजे थीटा झाला. तो हा थीटा म्हणजे काय? ओके. आणि फाय म्हणजे काय? फाय इज नथिंग बट द मॅक्झिमम अँग्युलर डिस्प्लेसमेंट. म्हणजे तुमची शिप मॅक्झिमम किती डिस्प्लेस होऊ शकते, किती अँग्युलर डिस्प्लेसमेंट येऊ शकतं, म्हणजे मॅक्झिमम ओमेगा पी किती येऊ शकतो. म्हणजेच काय, मला ओमेगा पी जर मॅक्स काढायचं असेल, व्हॉट इज द ओमेगा पी मॅक्स? आय वॉन्ट टू फाइंड फाय ना. So phi is nothing but the maximum angle turn from this mean position.
ओके सर.
म्हणजे मला मॅक्झिमम कंडिशन फाइंड आउट करायचे बाळांनो टीचिंग मध्ये. कारण मला सांगायचं, तुम्ही मॅक्झिमम कंडिशन जर डिझाईन नाही केली तर तुमची शिप उलटी होईल ना, एक तर पुढून किंवा मागून. तुम्ही डिझाईन करताना मला सांगा, तुम्ही हे क्रायटेरिया कसं केलं असतं ना, की तुमची शिप किती पिच व्हायला पाहिजे, अपवर्ड अँड डाऊनवर्ड. तर शिप तुमची अशी, आता शिप जर तुमची अशी असेल, अशी पीच झाली, ओके. शिफ्ट अशी असेल, अशी पीच, जर शिप तुमची सरळ झाली तर काय होईल? शिप जर तुमची सरळ झाली पूर्ण पीच होऊन, मग हे कुणामुळे होणार आहे? हे कुणामुळे होणार आहे? तर अँप्लिट्यूड्समुळे, त्या व्हायब्रेशनच्या अँप्लिट्यूडमुळे. मग त्याचा अँगल काय असतो? तो फाय असतो. म्हणून फाय इज नथिंग बट द अँप्लिट्यूड ऑफ स्विंग. सगळ्यांना कळलं असेल तर मला येस करा, मी पुढे जातो. अँड देन आय विल शो यू द डेरिव्हेशन. इज इट क्लिअर डिफरन्स? तुम्हाला पुढे समजेल, मी तो फाय का घेतलाय ना, पुढे समजेल. बघा, मी स्टार्ट करतो. सो आय विल स्टार्ट द डेरिव्हेशन. द पिचिंग ऑफ शिप इज assumed to take place with the SHM. I have already said that is a motion of axis of spin about the transverse axis is SHM. Okay. Now theta is the angular displacement of the axis of spin from the mean position after time t. Phi is nothing but the amplitude of swing or maximum angle turn from the mean position in the radian. It is also called the amplitude of swing. Okay. Now we know that SHM is represented by x is equal to x sin omega t or a sin omega t. This is the आता मला वाटतं हे डेरिव्हेशन आपण ऑलरेडी केलेलं आहे बऱ्याचदा. नो नीड टू गो फॉर अनदर. ओके. नाउ सिमिलरली इन दिस केस, when you are talking about a torsi, x is nothing but a linear system, and when you are taking an angular system or torsional system, आता लिनियर म्हणजे काय, टॉर्शनल म्हणजे काय, मॉडेल नंबर 3 मध्ये आपण जास्त समजणार आहोत. ओके. सो यू आर गेटिंग x is equal to linear, theta is equal to torsional. Okay. So what you will get, if x is equal to x, capital X sin omega t, what is x? X is nothing but the steady state amplitude, or you can call it as a maximum amplitude. Okay. So in this case, similarly, when you are taking in terms of an angular system or a torsional system, you can write the equation as theta is equal to phi sin omega o into t. That omega is o is nothing but the angular velocity of the SHM, and this angular velocity of SHM can be calculated as 2 pi upon time period, because we know that omega is equal to 2 pi upon Tp, or Tp is equal to 2 pi upon omega. Tp is called as a time period. Okay, clear? Now, angular velocity of precision. Now, see, this axis of spin OX is turning about axis of precision OY at what velocity? Omega p. What is it? Omega p, angular velocity of precision. If you are absent, you look the recorded lectures, see the recorded lectures, sorry. Okay. So omega p is by d theta upon d dt, we already derived. Okay. Now what is omega p? Take derivative of theta is equal to pi sin omega t into 0. So we are getting phi omega o cos omega o t. Okay. Now in the expression of simple harmonic motion, you know that, what you know? That omega p max, when you will get omega p is equal to omega p max. Okay. When you will get omega p is equal to max, when you have cos omega t, that this angle cos of this phi or cos of this angle omega 0 t is equal to 1, right? So I am getting omega p max is equal to phi into omega o, that is a phi into 2 by t. So now if anybody, आता तुम्हाला डिफरन्स कळला असेल, मगाशी मला कोणती प्रश्न विचारला की फाय आणि याच्यामध्ये डिफरन्स काय. बघा, जर तुम्हाला ओमेगा पी माहित असेल आणि जर तुम्हाला ओमेगा पी मॅक्सिमम हवा असेल, तर व्हॉट यू विल गेट, pi into omega. So when you multiply by this angle to this omega O, that is 2 pi upon Tp, you will get maximum angular velocity of precision. कारण जोपर्यंत ऍक्सिस ऑफ सी शेवटी फायनली माझा मॅक्झिमम गॅरोस्कोपिक कपल काय असणार आहे, सी मॅक्स इज इक्वल टू आय ओमेगा इंटू ओमेगा पी मॅक्स. कारण माझा बेसिक फॉर्म्युला सी इज इक्वल टू आय ओमेगा इंटू ओमेगा पी. सो व्हॉट इज सी? गॅरोस्कोपिक कपल. व्हॉट इज मॅक्झिमम गॅरोस्कोपिक कपल? So whenever you are designing that, the maximum gyroscopic couple should be I omega into omega p max. Is it clear? Okay. So finally आपण काय शिकलो आतापर्यंत की whenever I am applying this gyroscopic couple on the axis of spin OX, the axis of spin will turn or pieces around OY, and that is why the gyroscopic couple, that is reactive gyroscopic couple, will be created on the third axis. And the effect of this reactive gyroscopic couple is what? That we have understand when the ship is steering and when the ship is pitching. आता मला सांगा तुम्हाला इथपर्यंत कळलंय का? Have you understand this? Okay. And finally, जर तुम्हाला angular acceleration काढायचं असेल, now what is angular acceleration? Alpha is equal to omega into omega p, which is also called as the gyroscopic acceleration. Okay. आता ह्या केसमध्ये कुठल्या केसमध्ये, पिचिंगच्या केसमध्ये जर तुम्हाला अँग्युलर एक्सेलरेशन कॅल्क्युलेट करायचं असेल, मीन्स व्हॉट अल्फा इज इक्वल टू अँग्युलर एक्सेलरेशन ड्युरिंग पिचिंग. How will you calculate? Very simple. Alpha is equal to, now what is angular acceleration? Rate of change of velocity or angular velocity with respect to time ना. बरोबर ना? आपल्याला काय मिळालं? ओमेगा म्हणजे मला थोडक्यात मगाशी सिंगल डेरिव्हेटिव्ह घेतलं, मी डबल डेरिव्हेटिव्ह घ्यायला लागेल. व्हॉट इज डबल डेरिव्हेटिव्ह? मायनस फाइन ओमेगा 0 स्क्वेअर साइन ओमेगा ओ इंटू टी घेतलं, हे झालं. मग तुमचा हा झाला अँग्युलर एक्सेलेरेशन. मग मॅक्झिमम अँग्युलर एक्सेलेरेशन कधी असेल? दॅट विल बी मायनस फाइन इंटू ओमेगा 1 स्क्वेअर, मीन्स व्हॉट? व्हेन यू आर साइन ओमेगा ओ टी इज इक्वल टू 1. जेव्हा तुमची ही टर्म 1 असेल तेव्हा तुम्हाला अल्फा मॅक्स मिळणार आहे, दॅट इज मॅक्झिमम अँग्युलर वेलोसिटी. सो मॅक्झिमम अँग्युलर वेलोसिटी इज नथिंग बट मायनस फाइव इंटू ओमेगा 1 स्क्वेअर. इज इट क्लियर गाइस? इज इट क्लियर? हॅलो, हॅव यू अंडरस्टँड दिस डेरिव्हेशन? मी तुम्हाला शेवटचा भाग पटकन सांगतो, मग अजून एक लेक्चर मध्ये आपल्याला फक्त प्रॉब्लेम घ्यायचा आहे, तो मग आपण घेऊया नंतर. टेल मी, हॅव यू अंडरस्टँड एव्हरीबडी? मगाशी कोणी डाऊट विचारलं होतं, त्याला क्लिअर झालं का? फाय आणि थीटा मधला डिफरन्स? यू हॅड आस्क्ड मी.
Yes, sir.
Okay, Saurabh.
Yes.
Yeah, so Saurabh, if you are with me for a continuous 40 to 50 lectures, and when I will start a module number 3, that is a vibration, you will get more idea about the amplitudes and that maximum amplitude and all. You will get more idea. Okay. So now you
Okay,
just
sir.
understand that. Because here I have not explained you the concept of vibration. In the module number 3, I will explain the concept of vibration. So there you will understand what is amplitude and all. Okay. And why you have to limit the amplitude, because maximum amplitude creates a resonance. And what is resonance? That also you will understand later on. Okay. Now last is rolling. Now what is rolling? In case of the vehicle, I have shown you that if you are looking, if the observer is at the front, if you are looking at the front of the vehicle, the mx is nothing but the mx about x-axis. So about x-axis, if the vehicle is rolling, if the vehicle is leaning either side, then it is called the rolling movement. So mx was nothing but a rolling movement. I have shown you in that picture. Okay. So same. Now let us take understand the effect of gyroscopic couple on ship. Now what is the effect of gyroscopic couple on the steering? During steering, raise and lower the bow and the stern. And during pitching, either it is moving to the right hand side, or either it is moving to the port side, or either it is moving to the starboard side. And steering the effect by lower the bow, raise the stern, and vice versa. So these are the 4 conditions what we have stated: stern, starboard, port, and the bow. Now last condition within the 2 minutes, the effect of gyroscopic couple on the ship. First of all, you understand that there is a rolling of the ship. First of all, you understand that the ship will roll. Ship will roll, but there is no any effect of gyroscopic couple on the ship during the rolling. There is no any effect of gyroscopic couple on the ship. म्हणजे ship जरी तुमची रोल झाली तरी gyroscopic couple चा इफेक्ट होणार नाही. Now in the very starting lecture, I have explained you that for a gyroscopic couple to occur, परत बघा मी हे वाक्य परत सांगते. For gyroscopic couple, for effect of gyroscopic couple to occur, it is very important that axis of precision should be perpendicular to what? Should be perpendicular to x axis of spin. सगळ्यांना क्लिअर झालं? For an effect of gyroscopic couple म्हणजे reactive gyroscopic couple. For an effect of reactive gyroscopic couple to occur, axis of precision should be perpendicular to the axis of spin. Now let us take one by one. In case of the steering, axis of precision was OY and axis of spin was OX. It is perpendicular to each other, so we got effect. In case of the pitching, axis of precision was OZ because we were looking from the top view, and then only we can see the effect. Okay, and axis of precision was spin was OX. So these were perpendicular. So this was the case of pitching. So we got the effect. But is it clear? Is it clear up till here? But in this case, try to understand that. Can move forward? Yeah. In case of the rolling, your OX is equal to axis of precision and OY is nothing but the axis of spin. कारण तुम्ही जेव्हा रोलिंगचा इफेक्ट जर बघितला तर मला समोरनं दिसणार आहे. So that mx was the rolling moment of the vehicle ना. So मग जेव्हा शिपच्या केसमध्ये जेव्हा सेम कंडिशन आपण अप्लाय करणार तर शिपच्या केसमध्ये बाळगणं काय होतं लक्षात ठेवा. Axis of precision and axis of spin are same, that is OX. Means what? Axis of precision OX is parallel to the axis of spin. So I can say that axis of spin is parallel to the axis of precision. Clear? Is it clear? Axis of precision and axis of precision are parallel to each other because it is one and the same, that is OX. Because shift is rolling about the x-axis and similarly it is precessing about the same axis. So they are parallel to each other, they are not perpendicular to each other, and that is why we are not getting the effect. आणि तो रोलिंग आपल्याला कुठल्या प्लेन मध्ये दिसतं? प्लेन YOZ मध्ये. म्हणजे समोरनं जर मी बघितलं तर YOZ प्लेन मध्ये मला रोलिंगचा इफेक्ट दिसणार आहे. तो कसा दिसणार आहे? आय विल शो यू द एनिमेशन. See, can you see the rolling? So this is called the rolling. Okay, is it clear? So same I have in case of the rolling of the ship, same I have written here. Axis of precision is parallel to the axis of spin. Hence, for all positions, hence there is no effect of gyroscopic couple acting on the body of the ship. And for the effect of gyroscopic couple to occur, the axis of precision should be always perpendicular to the axis of spin.